Okay. So note equations of parabolas with a focus in directrix. Directrix is another new vocabulary word, right? But we do know what a focus is, and we've had some experience with focus. Today we're doing it with parabolas, though. We've seen with hyperbolas, it's kind of like a parabola, but sideways parabolas, right? Yes? And inside that sideways parabola, there was a focus. So it's essentially in the same place, but this time our parabolas will actually be functions. The set of all points equidistant from a point called the focus and line called the directrix. What? Equidistant. It's not equal. Equidistant. A focus is a point directly above or below the vertex. Since parabolas are only concave up or concave down, it will be inside the parabola. So if it's concave up, inside the parabola is above the vertex. If it's concave down, inside the parabola is below the vertex. Okay? Directrix. I'll show you a picture of what that is in just a sec. Any point on the parabola will be equidistant from the focus and directrix. So that's the directrix relationship. Any point on the parabola will be equidistant from the focus and directrix. After you have that written down, I'll switch over to a picture really quick. Those in the back, can you see all those? Okay, so like we did with the ellipses and hyperbolas, we drew all these out. This one's not as involved. Here's a picture of everything labeled. Let me see if I can just go make that a little. We also have a thing called latus rectum, which we'll use in the formulas. So maybe on, what do you have room for this? We're not doing... You'll have to put this at the top. We're not doing the patty paper activity. Oh, no, you have a graph, don't you? See that graph with those 2 points? Make it look like this and label everything. So your 2 points on your graph is right here and right here on your notes. And then you have this dotted line. That dotted line, which is below the vertex, okay, is called the directrix. The focus is that floating point inside the parabola. It has to be inside, so when it's concave up, like this picture is, the focus will be above the vertex. Okay, the latus rectum is a perfectly horizontal chord with slope 0 that intersects the parabola in 2 places and crosses through the center. Not the center, the focus. Sorry, not the center. Latus rectum has a slope of 0, perfectly horizontal, crosses through the center there. I keep saying center. I mean focus. Sorry. Okay, and any point, we said this on the directions, or on the definitions. Let me put this down. The set of all points equidistant from a point called the focus and the directrix. Again, the directrix relationship, any point on the parabola will be equidistant from the focus and directrix. So that's what these green lines are. Any point on the parabola, pick this point. I think this picture is a little bit off in scaling because the directrix should be up a little bit. But the reason I'm saying the directrix should be up a little bit is because this distance is equal to this distance, to the directrix. And you can tell it's off a little bit. Any point on the parabola, though, if you come straight down, perpendicular to the directrix, put the phones away, that length or distance is congruent to the same point being connected to the focus. You can do that all over the place. If I pick this point way up here, that length would be congruent to the length connecting the same point to the focus. Okay, so two new vocabularies, latus rectum and directrix. Now, just like our hyperbolas and ellipses, we have a bunch of little formulas to find, to solve these. Let's see, I need to go back to my notes. We're not going to do the patty paper example. Okay. The vertex form of a parabola. Isn't a parabola a quadratic? Yes, parabola, quadratic. So we've seen this top line many, many times this year. Y equals A times x minus h squared plus k. What does the A do to the graph? Brings in the arms. We have either a vertical stretch or a vertical compression. What does the H do to the graph? Horizontal shift, and we always think if it's contained within the grouping, we think opposite. What does the K do to the graph? Vertical shift, and it's after the squared is over, so that is same. Opposite, same. And it's not standard form. Cross out the word standard and put vertex form. It is called vertex form because we can see the vertex right there. Opposite, same, that's your vertex. And I'm going to change some of these C's. These C's I'm going to change to A's so we don't get confused. I'm going to change those to A's because it's the same A as this A. Okay, the vertex is opposite the H, same K. Opposite the H, same K. And that's, we've been doing that all term. Opposite, same. Axis of symmetry, we've already learned before. What is the axis of symmetry? When it's in standard form, yes. Yes. Negative b over 2a, yes, when it's in standard form. But when it's in vertex form, the axis of symmetry is the fold line that goes through the vertex. So the axis of symmetry and the vertex have the same number in the x position. Axis of symmetry, though, is a line. What axis would a vertical line slash through? Does it slash through the x-axis or the y-axis? X, which is why this says x equals opposite of h. The focus, that point floating in our parabola, that has a relationship to the distance any point on the parabola is from the directrix, is a point. Guess what? The focus is directly above the vertex or below the vertex, which means the x stays the same. All that changes is the y. So all three of these have opposite h, opposite h, opposite h. They all have the same x. What changes is the y. It starts with the vertex, k, that vertical shift, but then it's either shifted up or down, depending if a is positive or negative. Okay, so put plus 1 over 4a with the focus. And then we'll do an example here on number 1 and actually use that. The directrix, that horizontal line, is just reverse of this. This was k plus 1 over 4a. If the focus is above the vertex, the directrix is below the vertex. So that would be minus. Oops. I'm going to say a there instead of c so I don't confuse you. And the length of the latus rectum, which was the chord from here going through the foci to there, the focus to there is the latus rectum. It's the absolute value, because length has to be positive, of 1 over A. Okay. Now let's actually use these and figure out what they mean. We're going to do A and B. That's all we're doing on this worksheet. Identify all of the things that we just listed above. Okay? First of all, to identify the vertex, it has to be in vertex form. Vertex form says y equals all the other stuff. Is this y equals? No, so how do we get it to be y equals? Times by 2, or we could divide by 1 over 2. I think timesing by 2 is probably easier. So that's what we need to do first. Times both sides by 2. We need to get it in the right form. Times. Now don't put an equal sign. I'm going to put a yield sign. You can't just put equal signs everywhere, because y isn't the same thing as 1/2 y. They're different. So I'm going to say this yields the next step. I get y equals 2x squared. Now we should be able to see the vertex. The vertex comes from whatever number is being added or subtracted to the x within the parentheses. We do the opposite of that, plus the same of whatever number is after the square. So what number is contained within the parentheses being added or subtracted to the x? I heard it over here. 0. Do you see parentheses? That should be a clue that it's 0, because there's no number being added. I can even stick parentheses right there. There's no number being added or subtracted to x before the square, so it's 0. What number is after the square? 0. So our vertex is 0, 0. Horizontal shift and vertical shift or none. So it's still very similar to the parent function. The only thing that changed was the 2. What does the 2 do to the graph? Steeper. If you're multiplying by 2, you're going to go up more than you go to the side. You're going to rise more than you run. Okay, axis of symmetry. If you know the vertex, you should also know the axis of symmetry. Axis of symmetry is a vertical line. A line has to have an equal sign. Brindy, what axis does a vertical line slash through? Which axis do I slash through if I'm going vertically? Here's my axes. I slice vertically. Which axis do I slice through? The x-axis. That's why axis of symmetry is x equals. It gets confusing sometimes if you do x or y. So I just think, well, which axis is it cutting through? If it cuts into the x-axis, it's x equals. If it cuts into the y-axis, it's y equals. Okay? Anyone know what this equals? 0, because it should be the x-coordinate of the vertex. So it should be the same numbers. But axis symmetry is an equation, so make sure you have an equal sign. Now, the focus is a point. Guess what? The vertex and the focus are lined up vertically, so they have the same x value. So the focus is 0. So those 3 should all have zeros. Those red zeros, all in the x position. What changes of the focus is it's just, since this is positive 2, doesn't that mean it's concave up? Positive 2, concave up. So that means our focus is above the vertex. So all that changes is a vertical shift up. And we find that by k plus 1 over 4a. K was our, well, it's this, right? It's the vertical shift. What was k? 0 plus 1 over 4 times what was a? 2. Okay, so the focus ends up being the point 0, 1/8. Any questions? Vertex and axis symmetry were reviewed, but focus is new. Basically, you just plug into the formula I gave you, and you're good. The directrix is another thing we need. It's an equation, though, of a line. The directrix goes horizontal. Which axis do you cut through if you're going horizontally? The y. So this is y equals. It's almost identical to what we did in the focus, except for it's subtract. Oops. You take the y coordinate of the vertex, 0, minus 1 over 4 times 2. So the directrix is y equals negative 1/8. So it's an equation. The axis of symmetry is an equation, and the directrix is the equation. Axis of symmetry is x equals. The directrix is y equals. I think we have everything to graph. We don't need to graph the lattice rectum. Yeah, I think we're good. Okay, let's put everything we know on. Plot the vertex, 0, 0. Okay, the axis of symmetry is x equals 0. We show axis of symmetry by a dashed line, the fold line. Axis of symmetry is a fold line. And for axis of symmetry is x equals 0. It should slice through the x-axis at 0. Okay, what else can I put on my graph? The focus, we have a point, 0, 1/8. So 0, and then we go up 1/8. It's really close to that. F, that's my focus. My directrix is y equals, that's just slice through the y-axis. This is also a dotted line. Y equals 1/8, negative 1/8, excuse me. The focus is equidistant from the vertex as the directrix are. That gap between the vertex to the focus should be the same distance as the focus to the directrix. They should be congruent. And now I just need to see my parabola. How do I graph 2x squared? So, well, normally the ratios are what? 1 over 1 and 4 over 2. You guys remember those? But we have a multiplier this time, so we have to times by 2. So we're going to go up 2 over 1, and we have another one up 8 from the vertex over 2. From the vertex up 2 over 1, both ways, left and right. From the vertex up 8. Do I have the number 8? 2, 3, 4, 5, 6, 7, 8. And over 2. So I actually end up off the graph a little bit. Is the focus inside of the parabola? Yes or no? Yeah. Our graph's kind of small, but it's inside, which is it's supposed to be. Okay? We're just going to do number 2, and then we're done with this, and then we will do the easy thing. Any questions on number 1? Graphing that and finding focus and directrix are the new pieces. Okay, let's do B. And if you need to put some of your work into the space of the C, it's okay, because we're not going to do C. What's wrong with B right now? How come I can't just see the vertex right away? It's not in vertex form. Okay, let's see here. Maddie, how do I start getting Y by itself on part... Oops. Hold on. Hang on that, though. Okay. How do I start getting Y by itself? What's with Y that needs to be moved to the other side? And there's something else as well. Negative 8. What's on the outside? Because that's easier to move first. Negative 8. So how do we move the negative 8? What's the inverse? It doesn't say negative 8 subtract. It says negative 8 times. Divide. We're going to divide everything by negative 8. Okay, so we get y minus 2. Now, negative 8 is actually part of your a. Would that be the same thing as writing negative 1 over 8? Is dividing by negative 8 the same as negative 1 over 8? I think so. Times x plus 1 squared. If you write it like this, you can start seeing the vertex form. Okay. Cindy, how do I continue to get y by itself? Not y. We want to leave y there. Plus 2 to both sides. So we want this in order of vertex form. Y equals negative 1/8 times x plus 1 squared plus 2. Can you see the vertex just by looking at that? With your partner, would you show me the vertex? With your partner, would you show me vertex with fingers in the air? Find a partner, put your hands together, and show me the vertex. There you go. The vertex. Ooh, okay. I see. Yes, I don't know what this is. The 8's not involved in the vertex. Not involved in the vertex. Yeah. What about back row? What's the vertex? Comma. Negative 1, comma 2. Good. Opposite, same. Like I said, we're not doing C, so feel free to write in that space. Opposite, same. Okay? The axis of symmetry cuts through the vertex. It also cuts through which axis? So we say x equals. Karin, what number would it go with x equals for the axis of symmetry? What's the x of the vertex? Negative 1. So those should match. Same with the focus. Guess what? It also has the negative 1 in the x position. What changes is the y. The focus will be either above the vertex or below the vertex, depending on if the parabola is positive or negative. What is this parabola? Is it concave up or concave down? Concave. It's negative 1/8, so that's concave down. It opens down. Okay, so that means our focus is going to be below. We take the original y, which was 2, and we add that fraction 1 over 4 times a. But what was a? Negative 1/8. Negative 1/8. So to simplify this, you need to be careful. Follow order of operations. I would do, looks like we need to do multiplication first, huh? 4 times 1 over 8. What's that? Four divided by 8, isn't that 1/2? How do we divide by a fraction? Not magic. Didn't you say that last time too? Magic. It's what? What did you say? Multiply by the reciprocal. Flip and multiply. So this becomes negative 1 comma 2 plus 1 times 2 over 1. Isn't that just 2? So 2. Oops, there's a negative. This is negative. I was like, this is going to be above. What's wrong? 2 minus 2 is 0. That's our focus. This says -2/1 because I flipped it. This is -2/1. The last thing we need is the directrix, and then we can start graphing them. The directrix is very similar to the y part of the focus, but the focus does plus. What does the directrix do? Minus. So for the directrix, it's an equation, y equals, because the directrix is horizontal, slices through the y-axis. Y equals, everything's the same that we had here in the y part of the focus, except for we put minus 1/4 times -1/8. What did this fraction mumbo-jumbo become before? Because it's the same here. Didn't it become -2? 2 minus 2, so this time it's 2 subtract the -2. What is 2 minus 2? Oh, it's not 0. Wiggle, squiggle, plus, it's 4. Y equals 4. Okay, so now we just graph it. Make sure we know how to draw the parabola and we're done. Put your vertex on. No, we'll do purple. Vertex was, we found it, -1, 2. Axis of symmetry is x equals -1, so that is a dotted line, and you should label it axis of symmetry, x equals -1. Make sure the vertex is on the axis of symmetry. If it's not, you made a mistake. Okay, what else can we plot? The focus, -1, 0. That's my, marker's too thick. It's my focus. Okay, Dan, what else can I plot?
So you have on the notes.
Yeah. Jennifer, what else can I plot? I just plotted the focus. What else is there to plot? What did we do after the focus? Directrix. And what is the directrix? Y equals 4? Yeah, because it's an equation. So it's a line horizontally cutting through the y-axis at 4. That's the directrix. Bless you. I plotted this focus wrong. You know how I could tell that it was wrong? What's the gap between the directrix and the center right now? The distance. It's 2. And then this distance is 1, because apparently I can't graph anything with a 0 on it. It should be down here, -1, 0. So that's a check you should do. Make sure the focus to the vertex is the same distance as the directrix to the vertex. Okay, now I just need points for my parabola. What is my A? -1/8? Ugh. Okay, 1/1 times -1/8. So I'm going to rise -1/8 and run 1. So that means go down just a little bit and run 1. What was the other ratio we use with quadratics? 4/2. If you can't remember these ratios, you just plug in points into the equation. But since we have a multiplier, we have to multiply -1/8. So 4 times that fraction is -1/2/2. So we rise down -1/2 and run 2. Oops. And run 2. So you can see, because of the fraction, as a multiplier, it got wider. And that's it. Guess what, guys? After after today, our lessons are easier. We're going to, because the past few lessons have definitely used a lot of brain power. I swear I printed this. There it is. I have a whole bunch of this for you. This other yellow paper is the homework on focus and directrix. It's just one side. This is homework on focus and directrix. You don't have to finish the rest of the notes. Those are, I think, what we did was adequate. It's on focus and directrix. It's exactly like the two problems we did. Okay, does anyone know another name for slope? Ah, you already know it. Rise over run, we use that, sure. Rate of change. Do you guys already know how to find slope? How do you find slope? Rise over run, what's the formula? M equals? No, not mx plus b, that's slope-intercept form for an equation. Oh, what's the rise? Is rising up and down, are those x's or y's? Those are y's. y2 minus y1 over x2. So you already know how to do this. So this is easy. Oh, brain relief. But I'm supposed to cover it anyway, even though you already know how to do it. Yeah? I'll write it down here in just a sec. We're just going to hit a couple of these because you already know how to do them. Just remember how to do slope, which is average rate of change. I was just doing a hand drawing of Directrix and stuff. This one, that's what I want. Okay, on the top, let's just put AKA. You guys know what that is, right? You guys are teenagers. Of course you know what that is. You don't know what AKA is? Also known as LOL. What's LOL? Goodness. YOLO. What's YOLO? Yes, that's how you speak. Okay, AKA, also known as slope. Okay? AKA velocity. Velocity has a relationship to speed. Speed equals the absolute value of velocity. Because can you drive negative 55 miles per hour?
In reverse.
But aren't you still going positive even if you're going to reverse? If you're reversing at 55 miles per hour, that's crazy. Okay? Slope. We've already talked about, some of you guys said rise over run, which is the change of y over the change of x. See these triangles? Delta. Oh, good. So you've seen that before. The delta means change of y over change of x. Which is just, you guys already know this, y2 minus y1, x2 minus x1. Okay, so there's nothing new really. Maybe you haven't seen the triangle before. But these problems, they're just finding slope, which you guys know how to do. Okay, so number one, using the tables above, compare the three cars and their positions after t seconds. Which car is traveling the fastest? Justify your answer. We have car 1, car 2, car 3. How can we find which one's moving the fastest? Well, it depends what we're looking at. Are we looking at the fastest over time, the entire time? Or initial time. So there's some variables. Let's look at over 5 seconds, for the whole 5 seconds. Car 1, for the first 5 seconds, who's traveling the fastest? Well, we're going to just do y2 minus y1 over x2 minus x1. Okay? Now at car 1, how far has he gone at the beginning?
4 feet.
That's actually after 1 second.
On 0, oh yeah.
Oh yeah, 0.
Oh, interesting. 0.
Start at 0.
Okay? Now, actually I'm going to put that right here. 0, 0, right? So y2 would be not 0, but actually 16 minus y1, which is 0. Because generally y2 is to the right on the graph. And then the x's, what's the corresponding x that goes with 16? 5 minus 0. So 16 over 5. Sorry. Did that come out evenly? 3.2 feet per second. This is also a unit rate because it's per 1 second, which makes it a unit rate. Over the 5 seconds of time, we get 3.2. Average speed here is 3.2 feet per second. Average velocity, okay? And the speed is the positive version, which is also 3.2 feet per second. What about car 2? How would we set that up? Pretty close to the same way. Daniela, can you tell me how to do the plugging in to find how fast car 2 is going? So y2 minus y1, what would that be? Over what? What's the x value that corresponds to 26? 5 minus, instead of over, minus 0. Okay. 26 divided by 5.
5.2 feet per second.
Ooh, so far, who has actually been traveling the fastest? And does that actually make sense? Because in the end, he went 26 feet versus car 1 only went 16 feet. Maybe better initial acceleration, right? Okay, car 3. Car 3, 33 minus 0 over 5 minus 0. 33 over 5. Okay, which makes sense that it has the best speed because it goes the furthest, actually. It goes to 33. Okay, that's over the full interval of time. Number 2, what are the average speeds for the interval 0 to 2? Okay, so let's set that one up.
3 cars.
Car 1. Dan, car 1. Interval 0 to 2. How would I set that up to find, for car 1, its average speed for the first 2 seconds?
Okay, so equation would be
y2 minus y1, right?
yep, so 7 minus 0
Good.
over 2 minus 0.
Good. So if we're going from 0, we actually have to use 0 and not the one that's given. So we get 7 over 2, which can you do that without a calculator? What's half of 7? 3.5 feet per second. Car 2, we do the same. Let's see, Tatiana, how would we set up car 2s for the interval 0 to 2? I don't think it's 2. You need to do the y's first. 5 minus 0. And then the x's would be, what x corresponds to 5 from car 2? What? Yeah, 2 minus 0. So 5 over 2, can you do that without a calculator? 2.5 feet per second. So overall, actually car 2 went faster overall and further overall after the 5 seconds, but at the beginning, car 1 was actually going faster. And we could do the same thing for car 3. Car 3. It would be, looks like 5 minus 0 over 2 minus 0 equals, ooh, interesting, 2.5 feet per second. What does that tell you? Car 2 and car 3 have the same average speed for the first 2 seconds. And car 1 was actually had the highest initial speed. Okay, flip it to the back really quick where we see a nice quadratic. Here's your hint on this one. If you have a graph and you need to find the average rate of change for a given interval with a graph, I would just take a ruler, maybe, or something straight, and connect this up, nice and perpendicular, okay, and then you can do it, because then, really quickly, it says from 0 to 1.5, well, how high is the graph at 1.5, because that's going to be your y2. How high is that graph? Approximately maybe 40 minus, what's the y at 0? Because that's y1. What's that y? There's a number written right there. 300 over, your x is in the same order. 1.5 minus 0. 40 minus 300 is negative 260 divided by 1.5 is negative 173.3 repeating. That's the average rate of change. We don't have units. If this was speed, can the speed be negative? No, speed is always the absolute value. Okay, so homework for tonight. That yellow page, that one side, I'm focusing Directrix, and then I just have a couple on the average rate of change. You don't have to do the one that was scribbled out. Average rate of change, make sure you get this white worksheet. We have a test next Thursday. If you're not going to be here, it's imperative. The test will be multiple choice. It's imperative, though, if you're not here on Thursday, that you take it early. Doing it multiple choice so it can make it easy to grade and be on your grade in time before the term ends. Okay, good job today. Have a fabulous weekend. Make sure you get the worksheet.
Have fun and do this today.
Thank you. Come to my show. There's 3 weekends it runs.
Okay, guys. Thank you so much.
Thank you.
Thank you. Please bring the calculators back. Excuse me.